Okay. Extraction is another technique of separation. Is used for purification. You could have liquid solid interaction or solid liquid extractions. You could have liquid liquid extraction. The equipment that we are using for extraction is known as a separatory funnel. And when we are using separatory funnel, we want to learn how to use the separator funnel. When you are using the separator funnel, I have choice of two. I think this one looks better for my study. This setup is very simple. We have to use grease for the stopper, for the glass stopper, because we want to have a sealed system here, because we have liquids and we are going to use this in different directions later. The stopcock is closed in the horizontal position and is open in vertical position. It's a good practice to make sure your graduate cylinder is working to begin with. So as your separator funnel, sorry, you want to make sure that it is working. It's used for layers, mixture of two liquids that they are immiscible and have different density. So if you have two immiscible liquid in separator funnel with different density, the liquid with the higher density would be at the bottom layer, the compound or the mixture with the lower density would be the top layer. So because we have like two immiscible, one has to be organic, one has to be inorganic layer, and it's not guaranteed that always the top layer is the organic layer. Only if you are using ether as extracting solvent, and if ether has, since ether has lower density than water, ether would be the top layer. Aqueous solution is going to be the bottom layer. What is one of the characteristics for your compound with respect to the components, other components that you have in the mixture, that you can use extraction? Under what condition we can use extraction? Can I use extraction if I have mixture of two carboxylic acids? Extraction when we have like two carboxylic acid, can I use it? No. Why not? Because they have same acidity, and if you have same acidity for your compound with the mixture component of the mixture, when you add your reagent, they are going to behave similarly in aqueous versus the organic layer. So if you want to bring one of them to the aqueous layer, the other one is going to automatically come to aqueous layer. If you want to keep one in the organic layer, the other one would also stay in organic layer, because now you're dealing with two same nature, same functional group, same acids. So when you are using extraction, if you're doing acid-base extraction, you should have a mixture of acid and a neutral compound, or you should have a mixture of a base and a neutral compound, or you should have a mixture of acid and a base. So by nature, they should have different acidity for your compound, for your mixture to be using extraction for purification. The diagram that we have in this on page 41 is showing the acid-base extraction in general. So if you have a mixture of an acid and neutral compound, if you have a mixture of acid and neutral compound, you can add a base like a sodium hydroxide. Sodium hydroxide is going to react with the acid, with the carboxylic acid, and it changes to sodium carboxylate, or a salt of the acid, a salt of an acid, especially the sodium salt of the acid, is going to be soluble. We learned that in general chemistry. That in general chemistry it says if you have any compound contains group 1A, is going to be soluble. So any compound in group A, that's sodium, containing group 1A of the periodic table, that's sodium, potassium. So if you make a sodium salt of organic acid, that is going to contain sodium and is going to be soluble in water. Like if you have fatty acid and then you change that, you mix that with sodium hydroxide or potassium hydroxide, you make sodium salt of that acid, which is soap, and soap is soluble in water. So first, if you have a mixture of a neutral compound with the acid, you are going to add your extracting agent. So both of them are, they are going to, because they are organic compounds, they dissolve in organic layer. Then you add your sodium hydroxide. It would selectively and only react with acid and brings the acid to the aqueous layer. So when you have the acid in the aqueous layer, now the top layer, which is the organic layer, is going to have the organic or the neutral organic compound. The bottom layer is going to have the salt of the acid, and now you can separate it. To separate, you open the stopcock, you drain the lower layer. You want to keep that first last drop of the aqueous layer in. You don't want to get anything of the top layer mixed with the bottom layer in your receiving container. So that's how you separate the acid from the neutral compound. Now we are using multiple extraction. Why are we using multiple extraction? Because of the efficiency. The more number of extractions you have, more efficient is going to be your separation. Let's say the compound that you have that you want to bring to the aqueous layer is like 90% soluble in aqueous layer, but still is like 10% soluble in organic layer. So every time you're adding sodium hydroxide, 90% of that acid is going to go down to the aqueous layer. So 10% still is left in the organic layer. And if you separate the aqueous layer, add additional sodium hydroxide. By adding additional sodium hydroxide, you are going to take 90% of the 10% that is left. And you are going to collect in the same flask 2 portions. So first time you got 90% of the 100%. Second time you got 90% of 10% left, which is 9%. Now you have like 99%. Well, I use the percentage as example to make sure that you understand the preference of your compound to be more soluble in aqueous or more soluble in organic layer. But the actual term that is used in the for extraction in the book is the KD value, and that is the distribution coefficient. Distribution coefficient, basically it says how soluble is one compound in organic layer versus in inorganic layer, or how soluble your compound is in extracting solvent compared to the other phase. The greater that number is, the KD value, that means the solvent that you are using is more efficient. So if the value is like 10, that means your compound is 10 times more soluble in extracting solvent compared to the other phase, which is your inorganic in this case. So if it's 10 times more soluble in extracting solvent, is going to dissolve in the extracting solvent, and you are going to separate it using separatory funnel. But consecutive extraction, meaning that first you add your extracting solvent. You are going, after you add your extracting solvent, then you are going to shake it. Make sure the stopper is closed, is greased and closed. The stopcock is closed. You hold the separator funnel against the palm of your hand like this, and that's why it needs to be greased, because if it's not greased, this is loose, and since you are inverting like this, is going to get open, and all of the solution is going to, or some of it is going to spill on your hand, and that's not what you want to do. So you want to make sure that it's greased, so it's sealed, and you put like good enough pressure with the palm of your hand. You hold it like this, and you shake it. You shake it a couple times. Inside the fume hood, you are going to open the stopcock, and when you open the stopcock, it's going to release the pressure. So the pressure is going to leave the gas is going to, the build gas is going to leave the separator funnel and releases the pressure. So it would be released. Now you do that a few times, and you would hear like a fizzing sound that the gas is escaping, and you are going to continue that until you don't see any gas fizzing. If you do like really hard shaking, you are going to warm up your solution too much, and sometimes your ether, your solvent, actually vaporizing, and the new gas that is coming out is the vapor of the organic or low boiling point solvent that you have in there. So like 2-3 times shaking and venting is good enough. So you shake it first. After you add your solvent, you shake it first. Then you are going to vent it. That's V-N-V-E-T, venting. Venting, that means releasing the pressure. And the last step is separate. So to separate, the glass stopper must be out. If the glass stopper is on and I forget it, when I open this stopcock, is going to create vacuum because the top is closed and is not going to drain, or it's going to be like choking. And when it's choking, it's pulling air from the bottom, and you don't want to destroy that equilibrium or the levels that are formed, because you want to see that line of separation. So that might be disturbed and is not easy to get out. The level of the separator funnel with respect to the receiving flask, you see, up here, as soon as I start opening, it might tilt and it might spill outside, just like the beaker that I showed you the other day. I'm going to lower this. It has to be lowered to the level of the flask. So you would see, if I try to move it around, it's going to alarm me. It's going to have the alarming sound that you are moving this too much. Be careful, you might break it. But if it's up here, there is no alarm, and it might go out and spill. So we lower this to the level of the receiving flask. So you heard like 3 words from me that's going to stay with extraction. You're doing extraction multiple times, organic 1, and multiple times in organic 2 lab. So for extraction, there are 3 words to remember. For easy to remember, always follow the procedure, but these 3 words: shaking, that's after adding your solvent, shaking, venting, and separating. Shaking, venting, separating. Please write somewhere so you remember that those 3 words, just like the other day that I told you, like 5 minutes icing of the crystallization mixture, 5 minutes vacuum filtration to remove as much possible of the moisture and the solvent, and then 5 minutes placing in the oven for dryness, and you check it to make sure it's dry. But that's 555 stays for recrystallization. Shaking, venting, separating stays with extraction. So if I say consecutive, am I careful with the last part of the separation? Because if you put, let's say, 10 milliliters of sodium hydroxide and you don't separate, then you add another 10 milliliters of sodium hydroxide to repeat your extraction. Basically, you are using one extraction with 20 milliliters of the sodium hydroxide. So that is not called consecutive extraction. That would count as one extraction only. So you don't want to do one extraction. You want to do multiple extraction. That's why you have to separate it each time you are adding a solvent, new solvent, or extracting solvent. I'm going to go ahead and start the experiment. You help me starting of the experiment. go to the procedure and tell me what to do first. And can you tell me what is the characteristic for extracting solvent? How should be the extracting solvent? Can we use ethanol as extracting solvent? No, why not? Because it is soluble in water. In order to do extraction, you must have 2 layers, and if the 2 layers doesn't form, you cannot do extraction. So you have to make sure that your organic solvent, alcohol is organic solvent, it can dissolve many of the organic compounds, but is not going to be separating in 2 layers, so we cannot use alcohol. Okay, I'm going to measure 1 gram of the mixture, and with the 1 gram of the mixture that I'm going to measure here, I'm using the scale, and I want you to have a screenshot. So let's have a screenshot of the, and it's right here, not moving. So take a screenshot of the, okay, take a screenshot of that. The second screenshot is going to be, scale. Take a screenshot of the scale. Do you see it? Can you move closer down? Okay, sure. I don't see the camera myself. It's kind of hidden. Okay. Take the screenshot, please, now. And that is the mass of your compound. I tried to make it as close as possible to 1, but I didn't want to take too much of time. Then we are going to transfer that based on the procedure to a small earthenware flask. And we are going to add, I want to grease the stopper because I'm taking the funnel with us to the fume hood. Okay. I'm not going to bring the heater outside of the fume hood. It's not safe. So that's why I'm using my laptop. I just hope that no chemical gets a laptop this semester. I'm going to use heater to 10 milliliters of the ether to dissolve the sample in order to place it into the, to add to the separator funnel. So measure about 15 milliliters. Add to the flask. Dissolve it. Okay. When it's dissolved, I'm adding to the separator funnel. Add more for washing of the flask, about 5 milliliters. Just adding about 5 milliliters of the ether to wash the flask and transfer. This is just to make sure that everything is transferred to the. Can you tell me what's the next step? What do I need to add next? What do I need to add next? How much of sodium hydroxide do I have to add? You have the procedure, right? Tell me, please, how much of sodium hydroxide? 10 milliliters of sodium hydroxide. So I add 10 milliliters of sodium hydroxide. To the separator funnel. Cover with the greased stopper. Secure it like this with the palm of my hand. Shake it and vent it. I don't know if you can hear or not, but I could. The fizzing, releasing the pressure. So I did a couple times. And now it's time for me to place it on the separator funnel and the ironing to let it stay for the two layers to form. But can you see the two layers separation of the two layers here? Because both of them are same color. It's kind of hard, but if I bring it closer to you, I was hoping that you can see the two layers forming. Could you see the two layers? Okay. So shake it, vent it, and separate. So I'm going to separate the bottom layer. Okay. I don't want any of the top layer or the organic layer to go down. And I'm repeating the same part one more time. That is called the consecutive extraction. So I add another 10 milliliters of the sodium hydroxide to the separator funnel. Cover with the stopper, grease the stopper. Shake it, vent it. Make sure to close the stopcock before you put it in the top right position. Shake it, vent it and make sure it's closed. You put it back and put it on the ringer stand to make sure that it's going to be the two layers are forming. Can you, one of you tell me if you could see the two layers? Just want to make sure. If not, I bring like a black background or white background to see it. But if you can see it, that's perfect. Now we are separating the two layers. Look at the procedure to tell me what's my next step, please. What's my next step? You read that you have your lab notebooks, right? Just look at the next step. Tell me what's the step for me. Add the deionized water and 10 milliliters of the deionized water. We are going to do the same. What is the purpose of using the deionized water in this case? Deionized water, going to measure the 10 milliliter of DI water. DI water is going to wash the organic layer to make sure if there is any leftover of the sodium hydroxide or the salt of the acid that formed as a result of adding sodium hydroxide. It's all washed. So we clean, basically we wash the organic layer with water to make sure to recover any leftover of soluble or other soluble products. It does two benefits. It works in two ways. One, it making sure that the organic layer doesn't have any water soluble product. Second, is going to recover every water soluble product and place in the flask that we had with the acid. I told you the stopcock, the glass stopper must be removed in order to drain the bottom layer. I'm going to try this without removing, so you see what happens if you don't remove the glass stopper. See, the stopcock is open, but nothing is coming out. And then slowly we get like one drop at a time, and it's not working. See? Then I have to, because if it works, air has to go from the bottom. I have to make sure the top. Now it did create a vacuum. It's hard to remove it, but because it's greased, I was able to get it out. So that is the problem. If you have the stopcock, the glass stopper on, it would create vacuum and the liquid doesn't come out as easily. Can you give me my next step? What's next step? I did the separation. Now I have an organic layer. What I have in the organic layer is the neutral compound. What I have in the aqueous layer is the acidic compound, because I started with the mixture of two, that one was an acid and one was organic neutral compound. So we have the ether layer. The ether layer that contains the organic neutral compound is in the separatory funnel, and the other one, the aqueous layer, is in the flask. Going to leave on the bench top. Continue. Experiment. So your instruction, based on your instructions, you want me to pour the organic layer into a flask, and we need to label that as an ether layer. So I have a label for the aqueous layer, and I have a label for the ether layer. So I need to pour the organic layer into. It doesn't say drain because I have some aqueous still. Some of the aqueous layer still at the bottom of this. There's a drop, and it might be, I don't want to mix with that. So the organic layer is poured from the top. It's poured from the top into the flask that is labeled. Okay. You can take a screenshot of this. This is the screenshot for your third picture for the image. Now we have two separate layers. I close I use a cork for this to close it because I don't want to get ether in my face. I don't want to evaporate the ether in lab area. To evaporate later on, I'm going to place it in the fume hood because the ether is a highly is an anesthetic agent, and I don't want to be put in sleep at this point. I need to do experiments. Next step. Give me my next step. Dry it by adding spoons of the sodium sulfate and hydrosodium sulfate. Okay, how much of sodium sulfate should I add? I need to add enough to absorb the moisture from the ether. So if it's moist, what's going to happen? The sodium sulfate that I have is going to change to paste, is going to stay like together, it clumps up, it's not moving around. That means that I had some water mixed with the ether layer. So I need to add more. At this point, I'm adding another half a spatula. Okay. If it clumps up, that means it still is moist. If it starts moving, means it's enough. We can add some more. Okay, now the sodium sulfate is moving around. It doesn't stay in one place, it's moving around. I have this piece that is moving around. And because it's moving around, it's not clumping up anymore. That means I have added enough sodium sulfate and hydrosodium sulfate. And hydrosodium sulfate is going to get dehydrated by absorbing water from the ether layer. It's going to stay for a couple minutes to react to get the maximum moisture out, because then it's going to help me for the drying or evaporation later. We are going to use a clean beaker. Measure the mass of clean beaker. Use a screenshot of this also, because this way you know what is the mass for the beaker. Let me just double check it, please, to make sure that it was 0 to begin with. No, it wasn't 0. This is the mass for beaker. 49595. It's moving. Okay. 49600 you can use, or any number that you got on the screenshot you can use for the so next we have the mass, right? We have the mass. This was supposed to be labeled because when we have more than a group working using the same film hoods, we want to make sure that we know which one is our sample. But since I'm the only one working now, I didn't label it. We transfer the ether layer into the beer. Boiling point without getting any of the solid in. You want to make sure that all the solid stays in the flask. You're going to place this inside a film hood for it to dry. When the ether dries, the organic neutral compound is going to stay in the, at the wall of the beaker as like a white powder, and is our neutral organic compound. Because it's not the point of separating. We have separated now, but they are both in the solution form. We also have to recover it, because if we don't recover, we are not going to get the product. We don't know. There's no separation. It's just that there's no recovery. Separation has to follow by recovery. We have to end up with two solid compounds. Okay? So I'm going to place in the beaker in the fume hood. And we check it later. By the time we are done with my part of the experiment, that should be done. Sodium sulfate, because it's an anhydrous agent, should stay closed all the time. Otherwise, it would absorb the moisture from the room. And when it does absorb the moisture from the room, it gets like one piece rock. It won't work. It won't be efficient. And it's not going to be useful anymore. Now, we have our organic layer in the fume hood waiting for it to dry. The solvent dries up so we can recover the neutral compound from. Our aqueous layer, sodium hydroxide. What's in here now is the carboxylate ion basically. But when we add H to it, when we add acid to it, the acidity of weak acid, the solubility of weak acid or carboxylic acid is going to be lower in acidic solution. What you learned from the what you have learned from the general chemistry too, you have selective like precipitation by changing pH. You can precipitate your compound at a different pH. Acids are more soluble in basic solution, but they are not soluble in acidic solution. So my carboxylic acid now in a basic solution is in soluble form. It is soluble, but when I add acid to it, change the pH to acidic pH, the carboxylic acid is not going to be soluble, and we will see a precipitate coming out. When you see the precipitate, then we are going to practice what we learned from crystallization experiment last lab. How much of HCl should I add? 10 milliliters? Okay. Can I add 10 milliliters of the 3 molar? HCl. The quantity of the HCl, see what's happening? You can take the next screenshot. And Jaman, if you didn't hear me before, screenshots are necessary. That proves your attendance for the lab. Screenshots are supposed to be turned in separately as a separate file. So your solution must be acidic because we have a powder here, but to make sure that it is acidic, we should test for the pH. And to test for pH, we can get piece of pH paper, get a stirring rod, and get a drop of the solution to be placed on the pH paper, and it shows red color. That means the solution is acidic. When the solution is acidic, my acid component of the mixture has precipitated, and you see that it is cloudy. What should I do to make sure that I get complete precipitation or complete recrystallization? So the crystallization is going to be complete. Any response? What should be my next step to make sure the crystallization is complete? I have to place an ice bath. I have to place an ice bath. And I need the ice water. I have ice and the water. We place in ice for how long? 5 minutes in ice, and then we run the vacuum for 5 minutes, and we place in the oven for 5 minutes. And while we are waiting for the 5 minutes icing, I have to prepare my vacuum filtration. So I'm going to bring the vacuum filtration apparatus. I need the vacuum pump. I grab a vacuum pump. I always test it even though I know the right side is the vacuum and the left side is pushing air out. So I still test it to make sure that I'm attaching the vacuum to the right. Otherwise, if you attach to the wrong one, it will push air and it will pop out here. Since we need the mass of the product, we measure the mass of the beaker first empty. Later on, we measure the mass of the beaker with the neutral compound. we also have to measure the mass of the filter paper with the watch glass, because when we are done with the filtration and drying, we also need to get the mass of the product. So first here, then place the watch glass. Place the watch glass. Take a screenshot. That gives you the mass for your compound, 48.388. That gives you the mass for your watch glass and the filter paper. At the same time, it gives you another screenshot to include in your submission. Now, after the filter paper is weighted, I have the mass for the filter paper. I place in the funnel, add a couple drops of water to make sure that it's going to stay still. And now, you told me to place an ice bath at 10:54. Now it's 10:59. So it is kind of, yes, exactly, 5:55. It's okay if you miss one of the screenshots because you have to have at least like 3 out of 4 screenshots. Then because it's a long class time, is a long time for the lab. I don't expect you to be attached to your computer for 3 hours. You could take break. Even if you were in the lab, I would have allowed you to leave for, to take a sip of water and come back, or take a break for not more than like 3 to 5 minutes. But it's the same at home. But I want to make sure that you come back quickly and you follow me, you help me, you have you participate in questions, and you help me with the experiment. So now it's been 5 minutes already. I'm going to filter the product, turn on the vacuum, and pour the mixture. I'm mixing it before pouring because my point is to get all the solid on the filter paper. And if there is any leftover, I'm going to use the solvent, cold solvent. Since the solvent is water in this case, I'm going to use cold water to get the leftover. At the same time, that would be used to wash the precipitate. So the cold water that I have here is going to add some more ice to it. Make sure that I don't want. Okay, so I'm using some iced water to wash the glass and transfer. Wash the flask and transfer. A couple times takes care of 2 things: transferring all the solid to the filter paper. At the same time, is going to is used to wash the precipitate, the crystals that we have. Now, going to run it for 5 minutes, run the vacuum for 5 minutes, and when the vacuum is for 5 minutes, it takes most of the moisture out. Then we place in the oven. Okay, while that is working, we are going to go and check the organic layer that we had in the fume hood. We want to make sure that it's evaporating. If you could see from there, the volume has decreased and there's some solid that was on the side. I'm just mixing it or stirring it to induce more faster evaporation. It's going to stain the fume hood. I hope that by the time we are done with the other part of the experiment, vacuum filtration, this will be dried out. I added this wood stick or the wood chip in there. Often it allows the evaporation, it makes the evaporation faster. So it helps the evaporation process, especially when you are boiling a solvent. A wood stick is very efficient. And I'm trying to also use it here to make the evaporation take place faster. Outside of the beaker is very cold because this evaporation process is endothermic. So it makes the beaker very cold. Unrelated to this experiment, but in general, evaporation is an endothermic reaction. Has it been 5 minutes vacuuming? Not yet, right? 3 more minutes? Okay. Thank you for keeping track. Okay. I used too much chemicals on my hands. I'm going to wash my hands and I'll be back. Okay. With the spatula, I'm bringing the. Do you have any questions while we are waiting? Any questions for me? Let me know when it's been. It looks like it's been 5 minutes. I said 3 more minutes at 11:04. Okay. We can stop the vacuum. Remove the nuclear funnel. Transfer the crystals from the beaker funnel into watch glass. I'm kind of using the spatula to remove the filter paper, and I'm placing with the filter paper with our crystals on the watch glass that was already pre-weighed. Okay. Going to place in the oven for 5 minutes, and as soon as it's dry, are we measuring the melting point for the product? Yes or no? Do you remember? Or can you tell me if you are measuring the melting point? So we count for 5 minutes in the oven. Melting point of the benzoic acid and the dimethoxybenzene. Okay. We need the melting point for both compounds. I just checked the ether layer or organic layer. It still is not completely dry, but it's getting there. All the solvent is evaporated. I'm going to take you there also, so you can check the ether layer has been dry, but still slightly moist. I want to make sure it's completely dry before we measure the mass. Otherwise, we start with 1 gram, we might end up with a lot more. With some experimental air, we might have some extra because of the moisture, but we don't want to have like double. At the same time, I won't be able to get the melting point if the sample is not completely dry. So I'm going to let it stay inside the fume hood until it's completely dry. I can get some of it out, place it on a watch glass, and make it dry, because that's like just a quick sample. We take a small amount of it and place another watch glass to make sure that it dries faster for melting point purpose only. I did the same for the benzoic acid. The benzoic acid, I placed some of the sample on separate watch glass. Okay, it's time to check if the sample is dry. It might be dry, may not be dry, but if it's dry, we can take it to the instrument room and get the melting point. usually check for the paper. If the paper is crisp, then it's dry, but this paper still is wet, so it's going to be longer. It's going to take longer for it to dry. But the small sample that I had on the other watch glass, this part, it looks dry. So I can basically take this piece to the instrument to measure the melting point and wait for this rest of the sample to dry. I also got some of the ether dimethoxy benzene in another watch glass, so it's going to go to the instrument to measure the melting point. So if I'm measuring the melting point, which one should I measure first, the ether or the benzoic acid? That's my benzoic acid, and this is the ether. If I'm using the same machine, I think I'd be better off measuring the melting point of the ether first, because if I put the benzoic acid, which melts at much higher temperature, why much higher temperature? Because benzoic acid is a organic molecule with the carboxylic acid functional group, and it has an OH group. That means it's going to be hydrogen bonding and is a larger molecule, or is going to form that hydrogen bonding that is going to melt at much higher number. So if I'm using ether with the only dipole-dipole interaction, has lower melting point, is going to melt at lower temperature, then I don't have to wait too long for the machine to cool off. So that's why measuring the melting point for ether is much more, is a preferred action. Well, you might think that, well, I have so many different melt apparatus here, why don't I use others? But that's not the case always. Sometimes you have no choice. You have only one machine and you are using only one machine. So I'm putting the ether sample in first. Do you have the melting point for dimethoxybenzene? Theoretical value? If not, can you check it? Because if we have the theoretical value, we can find out if the sample has been purified properly or not. Did anybody find out? Melting point for dimethylbenzene? Okay, 54, 56. Okay. You can take a screenshot of the setup. This way, take it as close as possible, but it's not the webcam, so it's not going to be very easy. You can take a screenshot of this setup. Okay, this sample started melting a little early. Is a 49, 49 for initial melting. It's probably slightly, slightly. and 52. Good. Going to turn it off. I have the melting point for ether. Going to measure the melting point for benzoic acid. Get the sample. Use the capillary tube with open end down. We dip into the sample to get the sample into the capillary tube. I have very small sample, so it's hard to feed it in. And also, it could be that it's not completely dry, but if it's not completely dry, if it melts below 100, I have to put it back in the oven, get it dry for a longer time, and when it is completely dry, then I try it again. So, but it is worth it because we are waiting anyway, so we could do one melting. It looks dry because it's like when I touch it, it spreads, so it's not clumped together. So this is like completely powder, so it looks dry. Okay, we have the sample, no air bubbles, no gap, because air is not good conductor of the heat. Place in the sample holder, turn on, and monitor. So the thermometer showing temperature at 80 at this point, and the solid has not touched, which is good. Not melted. We don't want to melt under 100. That means the sample is not dry at all. Any questions while you're waiting? I want to make sure that you see the setup. Okay, 90 degree and has not melted yet. That's good news so far. Let's see what happens. Almost 110, but not melted yet. So the sample is dry. Just have to see when it starts melting, if it's pure or not. Okay, melted at 118. Started at 118 and completely melted at 120. 118 and 120. Yes. Going back to lab to look at the oven to make sure the sample is dry. You see this paper? Can you hear? It's very weak, but can you hear? When I say it's crisp, so that's what I mean actually. It's not moist, it's completely dry. And when the paper is dry, often the sample is dry. The sample looks dry. We just took it out. We're going to let it cool down because we don't weigh hot samples. We wait for a couple of minutes to cool down, then we would measure the mass. I'm going to also bring the Okay, we are going to measure the, was a connection problem. We are going to measure the mass of the watch glass with the benzoic acid part. And you can take a screenshot. Can you see the number? Okay. Take a screenshot. 48.69. Can you see it now? Take a picture. Okay. No? So recording number 48.91, because it stays at 9 for longer. 48.691. That's the mass. This was the mass of the watch glass, filter paper, and product. The mass for the beaker, the organic neutral compound, we didn't have the wood stick in there. Now I have to take it out. Just have to scrape the what is attached to it. Make sure it's clean and measure the mass for that. Okay. For the beaker or the neutral compound, 50.086. The second number was for the mass for the beaker with the ether sample. Okay, so with extraction, we started with the mixture of the two compounds, with the mixture of the benzoic acid with the dimethoxybenzene, which is ether. And when we use the separator funnel and extracting solvents, we separate them into solution form. Then we recovered them by drying the ether for neutral compound and making the acidic compound the solution that contains sodium hydroxide, making acidic with the sodium, I'm sorry, with the HCl for benzoic acid to precipitate. Now, I'm going to stop the recording in order to take the attendance. I'm going to take attendance and then I will answer your questions. We are done with the experiment, but we're not done with the lab yet. So I'm just going to stop the recording. We do have data analysis, we do have questions to answer, and also I need to take attendance, okay?